Hi all, welcome back. Today we will learn metallic and non-metallic characters in modern periodic table. So this is the modern periodic table. We know that metals, non-metals and metalloids all are present in the table. So this is the portion where metalloids are present, and metalloids are the substances or elements which possess characteristics of both metals and non-metals. So left to this portion all the metals are present, and right to this exact portion all the non-metals are present. So these are the positions where metals, metalloids and non-metals are present in the modern periodic table. So let's start the discussion with metals. So let's take an example of sodium first. We know that sodium is a metal. It has atomic number 11. That means it has 11 electron in its shell and 11 proton in its nucleus, right? So this sodium atom is now not in a stable state as it has not completed its octet. It is not a stable element now, right? So to get stable, this sodium will donate this electron. Okay, after giving this electron, the penultimate shell means what? This shell just before the valence shell, right? This penultimate shell now has the 8 electron in it, right? That's why after giving this electron, the sodium will become sodium ion and it got the stability now. So after giving, so this electron, number of electron reduced by 1, it becomes 10 now, right? So the negative charges are now 10 and the positive charges are 11. So this sodium ion we can denote as Na plus, as it has one positive charge more. That's why we can denote it as Na plus, right? So this is the sodium ion which is in stable form, right? So this is about the sodium. Let's take an example of magnesium. Okay, magnesium has atomic number 12 and it has 12 number of proton in its nucleus, right? So magnesium has to give these 2 electrons to get stable state. After giving these 2 electrons, the magnesium reduces negative charge by 2. So it has now 10 negative charge and 12 positive charge. That's why the magnesium ion now we can denote as Mg plus plus, right? So this is all about the magnesium. So let's take one more example, that is aluminium. Okay, so aluminium has atomic number 13. It has 13 proton in its nucleus. So aluminium has to reduce or lose all these 3 electrons to get stable state, right? So after losing 3 electron, the aluminium atom becomes aluminium ion and it has 3 positive charge more than the atom, right? That's why we can say that aluminium atom now become aluminium ion. Okay, so we can conclude from all these 3 examples that metals, they lose electron, right? After losing the electron, they form a positive ion, right? And one more thing here I want to mention, the element which lose the electron easily are the strong metal, right? Here in the case of sodium, sodium has to lose only 1 electron, therefore it will lose this 1 electron very easily. Magnesium has to lose 2 electrons, so the losing of electron become little bit difficult. Aluminium has to lose 3 electrons, so again the process become difficult, right? So here sodium is the strong metal. Why? Because it loses its electron very easily, right? So these are the characteristics of metal. Let's see it point wise. Metal lose valence electron. We have seen this. After losing the valence electron, they form cation. Cation means what? Positive ion. This is called electropositivity. Okay, losing the electron, formation of cation, this process is called as electropositivity. Metallic character is determined by ease with which valence electron remove. Okay, the element which removes its electron very easily are the strong metal, and the elements which lose the electron with difficulty are the less metallic character. They have the less metallic characters. Okay. Element is more metallic if lose electrons easily. So these are the characteristics of metal. Let's see about the characteristics of metal while moving down the group and across the period. Let's consider the example of group 1. So these are the elements in group 1. We know that while going down the group, the atomic size increases. We have already discussed this with reason, right? So now here potassium has the highest size. As it has more number of shell, the force of attraction of nucleus towards its last electron, that is valence electron, is less. So the potassium will lose its outermost electron very easily compared to the other previous elements, right? So we can say that as the size increases, the ease with which the electrons lose is increases. So easiness is increases. So the metals are the element which has tendency to lose electrons, and the element which lose the electrons easily are the more metallic in nature, right? So here the potassium is the strongest metal which has a high reactive metallic characters, right? The sodium possesses relatively less metallic characters. The lithium again possesses the less metallic characters. So we can conclude that as we go down in the group, the metallic character increases. Okay. Let's see what happened across the period. So this is period. We know that the size goes on reducing while go down in the period, while move from left to right in the period. Okay. And we also know that the force of attraction between the nucleus and the outermost shell of the last element in the period is very high. The electrons are held very tightly, right? Because in the same shell, the more electrons are present. That's why. Okay. So it becomes very difficult for this element to lose electron, right? Than compared with the previous elements, right? So the easiness is reducing. As the easiness is reducing, the metallic character is also decreasing. Understand? So while moving down in the period, while moving across in the period, the metallic character decreases. Let's see about the non-metal. So in non-metal we know that when elements accept electrons, see like this in the case of chlorine, it has to accept electrons, one electron to complete its octet, right? After accepting the electron, the chlorine atom becomes chlorine ion because one negative electron it has accepted. So one negative charge it has more than the positive protons inside the nucleus, right? That's why it has to denote as Cl minus. Okay. So again here the non-metals are formed by accepting the electrons. The non-metals accepts the electron. After accepting the electron, they form a negative ion, that is also called as anion, right? Let's see the statements. So non-metals accept electrons, they form anion. This is called electronegativity. Non-metallic character is determined by ease with which electron accepted. So in the case of chlorine, the chlorine has to accept one electron, right? But in some other metals, some of the element they have to accept 2 electrons. Some of them they have to accept 3 electrons to complete their octet. So the easiness of acceptance of electron goes on reducing here, right? So chlorine has a highest easiness to accept the electron. So the chlorine is the highest non-metallic character possessing element, right? So it is a strong non-metal, right? So element is more non-metallic if accept electrons easily. Understand? So this is all about the metals. So let's see the gradation in non-metallic characters while moving down in the group. So let's take an example of this group. Here we have seen that the metallic character increases because the easiness of removal of electron is increases, right? So as the metallic character increases, the non-metallic characters goes on decreases here. Understand? Metallic character increases, that means non-metallic character decreases, right? So let's see what happens with the period. We have seen while going across the period, metallic character decreases, okay, because it has decreases the easiness of losing electron, right? As the metallic character decreases, non-metallic character increases, because all these elements, they have to accept the electron to complete their octets. See here, nitrogen, it has to accept 3 electrons, oxygen has to accept 2 electrons, fluorine has to accept 1 electron, and the fluorine is the element which can accept the electron very easily because it has to accept only 1 electron. So it is a strong non-metal, right? That's why we can say non-metallic character goes on increases while going across the period. Okay. So let's see the conclusive statement. While going down in a group, see, the metallic character increases, non-metallic character decreases. Okay. While going left to right in a period, non-metallic character increases, metallic character decreases. So this was all about the gradation in metallic and non-metallic characters in the periodic table. Hope you understand the concept. To know more about the other concepts, stay tuned with me. Till then, thank you. Bye.